Hello, Bobcats. The last video about stoichiometry got cut short, and so I didn't get to do some example problems. And so in this video I thought I would go ahead and print out some example problems, and you can find these on the Canvas site, and you can print it out and follow along with me on this video. So we're just going to do about 5 different example problems on stoichiometry to practice. Now in this one, what we have here is we've got hydrofluoric acid, HF, cannot be stored in glass bottles because compounds called silicates in the glass are attacked by the hydrofluoric acid. Now sodium silicate, Na2SO3, for example, reacts as follows. So we have 1 mole of sodium silicate reacting with 8 moles of hydrofluoric acid to produce 1 mole of silicon fluoride or fluorate, sodium fluoride, and water. And so what we're going to do is we're going to practice some problems with stoichiometry. Anytime I have stoichiometry, I like to write my information underneath each of the samples, or the substances, sorry. So how many moles of hydrofluoric acid? So this, I'm going to go question mark. I want to know how many moles of hydrofluoric acid there are. And then are needed to react with 0.300 mole of the sodium silicate. So again, I'm going to start my problem by asking, I want to know how many moles of hydrofluoric acid, and it's important to do the units for both the measurement and the substance. And I start with 0.300 mole of the sodium silicate. Now I'm already at the mole, so all I have to do is do a mole-to-mole comparison of going from the sodium silicate to hydrofluoric acid. So if you notice, I got to go from sodium silicate, I've got to get to hydrofluoric acid. So I'm going to use the coefficients in the problem. So for every 1 mole of sodium silicate, and I put it on bottom because it's on top here, for 1 mole of the sodium silicate, I'm going to have to react 8 moles of the hydrofluoric acid. Remember, the 8 comes from the coefficient here. Cancel the units I can cancel, and since I'm looking for moles of HF, and this is moles of HF, I just multiply 0.3 times 8. So I'm going to get 2.40 moles of hydrofluoric acid. And I have 3 sig figs here, so I want 3 sig figs in this answer. Now I'm going to go to a different color to show you, because now I want to use the information here. So I'm going to use the same reaction, but I'm going to use different information. So I want to know how many grams of sodium fluoride. So I go over here and I want to know how many grams of sodium fluoride from when form, that's supposed to say form, when 0.5 moles of hydrofluoric acid reacts with excess sodium silicate. So now I have 0.500 moles of this hydrofluoric acid. So it's an 8:2 ratio. So again, I start off, I want to know how many grams of sodium fluoride I can produce when I react 0.500 mole of the hydrofluoric acid. Now again, I'm already in the mole, and the only way I can go from one substance to the other is to the mole ratio of the coefficients. So I have 8 moles of hydrofluoric acid, HF, so I go 8 moles of HF, and then we'll produce 2 moles of sodium fluoride. 2 moles of sodium fluoride. And when I cancel the units, I'm at moles of sodium fluoride. But I don't want to stay at moles, I've got to get all the way to grams. So I got to use molar mass. So 1 mole of sodium fluoride That's 22.99 plus 19, so that's going to come out to be 41.99 grams of sodium fluoride. Moles cancel. So grams of sodium fluoride, that's what I'm looking for. So now I'm going to go 0.5 times 2, which is 1, times 41.99. So take that, divide by 8, and I will get 5.25 grams of sodium fluoride will be produced when I react 0.5 moles of hydrofluoric acid. So in the next one, let's get a different color. Let's go with green here. We know how many grams of sodium silicate. So now I'm back to this. How many grams of the sodium silicate can react with 0.800 grams of the hydrofluoric acid. So again, I'm just looking at the reactant. So it's a 1 to 8 ratio. So in this case, I start again. I want to know how many grams of the sodium silicate will react with 0.800 grams of the hydrofluoric acid. Well, I'm in mass, so remember, the only way I can go from one substance, HF, to the other, sodium silicate, is through the mole ratio. So that means I have to go from mass to moles, which means I'm going to use molar mass. So 1 mole of hydrofluoric acid is, that's 19 plus 1.01, so it's 20.01 grams of the hydrofluoric acid. Now I'm going to go from the hydrofluoric acid and compare it to sodium silicate. So that's 8 moles to 1 mole using the coefficients. So 8 mole of HF will react with 1 mole of the sodium silicate. Cancel the HF. Now I got to go from moles of sodium silicate to grams of sodium silicate. So mole to mass is molar mass. So 1 mole of sodium silicate will have a mass of 122.07 grams of the sodium silicate. Moles cancel, and I've got grams, and that's what I'm looking for. So it's 0.8 times 122.07 divided by 20 divided by 8, and that should come out to be 0.610 grams of the sodium silicate. So that says I need 0.61 grams to react with the 8 grams of HF. Okay, so there's some examples right there. Let's do a couple more examples before we finish this video. In this case, I've got a reaction here. It says several brands of antacids use ammonium hydroxide to react with stomach acid, which contains primarily hydrochloric acid. So we're reacting aluminum hydroxide with hydrochloric acid. We're going to produce the salt, which is aluminum chloride, and water. So this is a strong acid-base, in other words, acid-base reaction. Now to balance it, because that's the first part, is balance the reaction. And remember, all stoichiometry depends on the coefficients of a balanced chemical reaction. So let's balance this reaction. If I look at the OHs, I've got 1 hydroxide here, and I've got 3 hydroxides on the reactant side, and I have 1 hydroxide on the product side. So I need to put a 3 here, which means now I have 3 hydrogens. So go back over here, I only have 1, so I put a 3 chlorines. So go back to the other side, 3 chlorines, and then 1 aluminum, 1 aluminum. So now it's balanced. Remember, that's not a 0 here. These are 1s. We just don't write 1. So So the next question is how many grams of HCl. So I want to know how many grams of HCl are required to react with 5 grams of the aluminum hydroxide. So I'm looking at a 3-to-1 ratio when I do the mole ratios. So let's start out. I want to know how many grams of HCl will react with 5.00 grams of aluminum hydroxide. So now remember, to go from one substance, aluminum hydroxide, to the other, hydrochloric acid, it's got to be through the mole to mole ratio. So I'm in mass, so I got to go to the mole using molar mass. So 1 mole of aluminum hydroxide has a mass of 78.01 grams. Mass cancels. Now I'm at the mole, and so I can go from moles of aluminum hydroxide to moles of hydrochloric acid. So that's 1 mole of aluminum hydroxide for 3 moles of hydrochloric acid. 1 mole of aluminum hydroxide will react with 3 moles of hydrochloric acid. Okay? Now aluminum hydroxide is canceled, and I don't want to know moles of hydrochloric acid. I want to know grams, which is mass. So mole to mass, I need molar mass. And so 1 mole of HCl has a mass of 36.46 grams. It's molar mass. Moles cancel. I'm looking for grams. That's what I've got. So I'm going to go 5 times 3 times 36.46 divided by 78, and the answer should come out to be 7.01 grams of HCl. So I need 7.01 grams of HCl to react with 5 grams of aluminum hydroxide. Now the last question is grams. How many grams of water? So I'm going to use a different color, and we're going to look at for how many grams of water. Putting it in green. I know it doesn't show up very well in green, but that's green. I want to know how many grams of water when I react with 5.00 grams of aluminum hydroxide. So now I'm looking at aluminum hydroxide and water. So let's get started. I want to know how many grams of water will be produced when I react 5.00 grams of aluminum hydroxide. Now remember, to go from one substance to the other substance, I need the mole-mole ratio. I'm in mass, so I got to go to moles using molar mass. So 1 mole of aluminum hydroxide has a mass of 78.01 grams of aluminum hydroxide. Grams are gone. Now I'm at the mole, so I'm going to go from moles of aluminum hydroxide to moles of water using the mole ratio of this with the coefficient. So it's a 1 to 3 ratio. So for every 1 mole excuse me, of aluminum hydroxide that I react, I'm going to produce 3 moles of water. And the aluminum hydroxide cancels, and so I'm going to go from moles of water to grams of water. So 1 mole of water has a mass of 18.02 grams. That's the molar mass of water. 1 mole is 18.02 grams. Moles cancel, and so I'm looking for grams, and that's where I'm at. So it's 5 times 3 times 18.02 divided by 78.01, And so we would get 3.46 grams of H2O produced when I react 5 grams of aluminum hydroxide. And so there's some practice problems for you. Remember, this typed up sheet is on Canvas, so you can print it out and watch this video and do the problems along with the video. And I hope you have a good day.